Over to you, Neha.
Okay, so good evening all. Today we will be continuing with the last class, that is Etabs modeling. Today's session will be handled by me, Neha Andrews, Junior Engineer, Structural Department. So in the last class, I have told you how to convert a drawing file to DXF file. So I'll explain it briefly once more. So first you need to draw the beam column layout in an architectural plan. After that, you need to draw the central line of that beam column layout. So central line will be drawn using the multi-line command. So after drawing the central line, we need to extract that central line from this beam column layout. And after that, we will be doing two corrections, that is overkilling and purging. So purging is used to delete the unused layers and overkilling is used to delete the overlap lines. So after extracting that both lines and doing this correction, we will be copying that central line to another drawing file like this. So here the first central line represents the ground floor and second one is for the first floor. So when you look into this architectural plan, this is a G+1 building. So there will be three beams, that is beam for the ground floor, beam for the first floor and beam for the terrace. So here I have only drawn two central lines which represents the first ground floor and the first floor. So when you look into this ground floor and first floor, you can see that there is changes in the beam layout. So there are more changes in the layout. So but when we compare first floor and the terrace floor, there is only minor changes. You can see that here all the dimensions are same. So here this layout, this beam layout, beam coming to it, everything is almost same for the first floor and the terrace floor. But comparing it with the ground floor, there are major changes in the beam layout. So I have only drawn the central line for the ground floor and first floor. So if we need the terrace floor, we will be replicating the central line from the first floor and we will be replicating it to the terrace floor, which is much easier than drawing the central line. So I have drawn only two central line here for the ground floor and the first floor. So after that, I'll be saving this file as DXF, that .dxf format, that is file type will be .dxf. So after saving this file in .dxf format, we will be importing it to the Etabs. So when we open the Etabs, we need to import this DXF file into Etabs. For that, we will be going to File, Import, .dxf file flow, .dxf file of floor plan. So we will be selecting the DXF file which we have saved. We will be opening it. So here we will be ticking all the things, and these all I have explained in your last class. So the unit will be in mm. So we will be starting at the beam size of 20 by 40, column size of 20 by 40, and floor properties, that is the slab. We will be starting with the thickness of slab 110 mm thickness will be starting. So next is the story level. So this represents where we need to, at which level we need to import this DXF file, at which floor or which level we need to import this DXF file. So I'll be selecting the ground floor. Here I'll be changing 1000 to 1 mm and OK. So the DXF file, we need to save this. Then this Etabs is asking to save the DXF file. So Etabs file. So we need to give a name, Etabs 123 or something. So we'll be saving this. So as you can see, this DXF file, that is the central line of the ground floor and central line of the first floor, has been imported. So the right window shows the 3D and the left window shows the top or plan view. So I have imported that DXF file in the ground floor level. So that's why both the central line has imported in the ground floor. So next we need to assign the story height. So for that we need to go to edit story and grid system, modify / show story data. So in this tab, we can edit, we can add the number of floors, we can delete the number of floors, we can input the height of each floor. So as you see in the architectural drawing, so our architectural drawing have ground floor, first floor and terrace floor. So we need to next step is to enter the height of each floor. So next, here we need to enter the height from the base to the ground floor, that is base of the foundation till the ground floor. So in this particular villa, the foundation is pile foundation. So we need to enter the depth of fixity of that pile. So depth of fixity as per code is 10 times the diameter. So 10 times the diameter, say the diameter of a pile is 500 mm. So 500 into 10 is 5000. So 5000 mm is 5 meter. So the height of pile or the depth of pile is depth of pile is 5 meter. So we will be entering the value of 5 here. That is from the base of the pile till the ground floor. From the base of the pile till the ground floor, the height is 5 meter. So the next height is from ground floor to first floor. So from ground floor to first floor, you should enter the height. So this height you will be getting from the architectural or the sectional drawing provided by the architect. So you can measure the floor to floor height from the section drawing provided by the architect. So say the height of floor height of ground to first floor is 3 meter, and the floor height from first floor to terrace floor is also 3 meter. So we have entered the height of floor height of each floor, and after that we will be refreshing the view. Okay, here also refresh view, and okay, so the story height has been set. So let's check the story height. So the here you can see the story height, that is ground floor z is equal to 5 meter. That is from base point, that is the base of the foundation, to the ground floor, the height is 5 meter. So if you move up, there is first floor, that is z is equal to 8 meter. This 8 meter represent the height from the base till the first floor, that is 5 plus 3. So 5 plus 3 is equal to 8. And next is the terrace floor, that is the height from the bottom base to the terrace floor. So this is how we input the story heights. So after that, you can see here the floor plan, that is the first floor plan and the ground floor plan, both have been imported in the ground floor itself. So we need to stack this first floor above the ground floor. So this beam will be coming above the ground floor. So we need to move this beam, or we need to stack this first floor beam layout to the ground floor beam layout. So for that, we need to select this beam layout. There is an option called move here. In your keyboard, you can click Ctrl plus M. It's a shortcut. So click move. Next, you can pick the 2 points. You can choose the option pick 2 points on the model. Click this option. First, you need to pick the end of the first floor. The second point, you need to pick the same end for the ground floor too. So if I pick top left portion in the first floor, same top left portion should be picked on the ground floor. If I pick top right portion on the ground floor, first floor, the same top right portion should be selected or picked in the ground floor too. So I have picked the 2 points. Next, I need to enter the distance. So as I said, from ground floor till first floor, the height is 3 meters. So delta Z height I will be entering as 3 meter. Next, I will be applying. So as you can see in this 3D model, this is the ground floor, and above that, the first floor has been stacked. So while moving this plan above, we can like that we can stack all the floors above one above the other. So the ground floor plan has been imported. The first floor plan has also been imported. Next, we need to import the terrace floor. We need to import the central line, or we need to import the beam layout for the terrace. So for that, as I said, the terrace floor is similar to the first floor. We can replicate this first floor plan to terrace floor. So I will be selecting this first floor plan. Here there is an option called replicate, or the shortcut is Ctrl plus R. So I'll be selecting replicate, and I'll be selecting story here because I need to replicate this first floor to next story, that terrace level. So I will be selecting story option here, and I'll be clicking terrace because I need to replicate this first floor to terrace. So I'll be clicking terrace here, and I'll be applying it. So as you can see, the first floor plan is replicated to the terrace floor. So this first floor I have selected and I have replicated it to the terrace floor. So now let's look into this window. So in the terrace floor, the first floor plan has been replicated. So now all the 3 beam layouts has been imported or has been modeled into this Etabs. So after that, we need to make the corrections in the terrace floor. As I said, it is much similar, but there are difference. So let's look into this AutoCAD about this difference. So when we look into this beam layout, the only difference is that these two beams are missing, isn't it? All other portion, it's similar. It's same as that of this. Only difference is that this these two beams are missing. So in the terrace floor, we need to delete these two beams. So moving back to this Etabs. So I need to delete these two beams. But when we selected these two beams, the whole beam has been selected. And if we delete it, the whole beam will be deleted. So we don't need that. We only need to delete this particular length. So for that, we need to split the beam. So we need to split the beam. So in order to split the beam, I'll be selecting that beam. And after that, I'll be going to this option. This option, it's called divide frames. So I'll be selecting that. After that, look into this first option, divide into two frame objects. So if I click apply for this particular thing, this entire frame will be divided into two equal parts. I'll show you. So I have applied this. So look, this was a single beam at the first time. So when I clicked this, it has been divided into two equal parts. I don't need that. I only need to split at this point. So I'll be undoing it. And the second option is the option that we need to split the beam. So second option is break at intersection with selected frame and joints. So I need to select the frame and I need to select the joint at which I need to split the beam. So I have selected the frame and I have selected the joint at which I need to break the beam, and I'll be clicking apply. So the beam has been splitted as I need. So it's easy for me to delete this particular beam. I'll be clicking that beam and I'll be applying delete. So that beam has been deleted. So the next beam is this vertical small portion. So here also it's the same method you should apply. So I'll be selecting this frame, I'll be selecting this joint, and I'll be clicking apply. So this beam has been splitted and I'll be deleting it. So that's the terrace floor layout. So I have imported the ground floor, first floor, and I have replicated the terrace floor from the first floor, and I have made the corrections and made the beam layout. So this is the first step of importing the beam. So these all central lines represents the beam. So the next step is to place the columns in position. So columns should be placed as per the beam column layout. So now let's look into this plan. Here, a column is at this point, this joint here and here too. So likewise, I need to place the column in all the points. So here is an option called quick draw column. So I'll be selecting that and I'll be selecting the property. I'll be changing here to column 20 by 40. After that, I can place this column like this. But when you look into this column is oriented horizontally, but in the architectural drawing you can see this column is oriented vertically. So I need to change the axis. So for that, I'll be undoing it, or there is also another method that I will show you. Before that, if you click change the angle to 90°, so this column has been oriented vertically so that it's easy for us to place. Okay. So when you look into this 3D drawing, the column has only been placed from base to ground floor. So we need the column which should run throughout the building, throughout the height. So for that, here there is an option called one story. We need to select it to all stories. So the difference is that when one story is selected, the column will be placed on that particular story height only. That is, since I have placed this column in the ground floor, this column will be placed at the from base to ground floor only. So if we select all stories and if we place a column at a point, this column will be run throughout. So I'll be showing you that. So column 20 by 40, and I'll be placing this column here. So look, when I change the option to all story, this column has run throughout the building. So that's the difference between one story and all story. So it's easy for us to pick this all stories option and consider this column which is only in the one story. We can replicate this column. So there's an option called replicate. As I said earlier, we can just replicate this column from the ground floor to first floor. Just apply. So now the column has been replicated to the first floor. Okay, once more you can select this column and replicate it to the terrace floor too. So after that, this has been replicated and this has been run throughout the entire building. So that's how we can replicate the column. And the easiest way is to pick all stories so that the column will be placed at all stories. So the column should be placed here. So if we look into this beam column layout, this particular column, its direction is horizontal direction. So I have placed the column in a vertical direction. So in order to change the axis, after placing, select that column. So this column has been selected in all the throughout the building. Go to assign, frame, local axis. After that, change the angle to 0 and apply. So this column has been rotated. Okay. That's the option of how to change after placing a column. So I have placed all the columns in this left portion. Now I need to look for another thing. So here there is a column at this junction and at this corner too. So I'll be placing that column at that portion, at this portion, and also here. Here, so likewise, you should place all the columns as seen in the architectural drawing. Here. Here, I am not getting the joint. You can see I am not getting the proper joint. So I need to divide these frames. So I'll be selecting these frames and I'll be dividing it. So after that, I'll be placing the column. So now you can see I have got a joint here. And after that, I have placed that column. I'll be changing the angle. Okay. I have almost placed all the columns. Okay, now this column is pending. And here I need to measure the distance from the AutoCAD. So I need to measure the center to center distance of this column to this column. And it's 2.4 meters. So I need to replicate a joint because I will not get a joint here to place the column correctly. So I need to make or create a joint here so that I will be able to place the column on correct position. So for that, I'll be picking a joint from here and I know the value, that is it is 2.4 meter from this joint. So I'll be replicating this joint. So this is the y direction and it's minus y direction. So I'll be entering a value of minus 2.4 and I'll be applying it. So I have got a joint here. So I'll be placing the column at this position. Okay. So now I have placed all the columns. So the next step is to delete the columns, delete the unwanted columns in the story. So when we look into this beam column layout, you can see that there is terminating column, there is floating column and all. So in the architectural drawing, you can see that in the first floor, there is an open terrace, isn't it? So since there is an open terrace, there will not be any slab above it. So when you stand here, you can see the sky. So that means there will not be any beam or any slab at top of this portion. So that's the reason why I have deleted the beams and slab here, because there is no portion. It will be open to sky. So at this portion, there is no point of raising this column till the terrace level, because there is no beams at the top portion. At this portion there will be no beam, so uh, uh, there is no option to raise the column. There is no need to raise the column at this terrace level. So we will be terminating this column at the first floor level. Till this level, this column will be terminated. So we need to delete that column at the terrace level. So since we have placed that columns, look, this column we need to delete at this portion. So since we have placed that column or choosing the option all story, this column has been run throughout the building, but we don't need that column at the terrace level. So we need to delete that column at that particular portion. So look, so here this will be like this, because here at this first floor there is open terrace and there is no beam at the top. So this column is of no use. So we need to delete this column. So for that, I'll be choosing this column. So when I choose or when I selected this column, the entire column was selected. So if we select like this and if we delete, the entire column will be deleted. So we don't need that. So we only need to delete the column at this particular story level, so that I'll be changing all stories to one story, and after that I'll be selecting this column. So since I have changed from all stories to one story, and after selecting choosing this option, column at this story level has only been selected. So it's easy for me to delete that column at that particular level. So this column will be from the base to the first floor only. So after that, we can look into the next column. So here there is also another terminating column at the first floor level. So we can see. So I have placed a column at this position. So when it comes to the first floor, it it will be passing through this ventilation and this window. So it's not good for a column to pass through a window. So I have terminated this column at this level. So the second column I have terminated from ground floor, terminated till first floor. So I need to delete that column too in the first floor alone. So I have selected that column in this floor and I have deleted that. So I have deleted that. So the next, you can see there is a floating column here. So when I delete when I have deleted this column, and that is when I have terminated this column in the first floor level, there is a need to transfer this total load. There is a need to transfer this load from the terrace beam to the first floor, that is to the basement. So there is no column available there. If we have not provided a column here, this much portion will be cantilevered. So cantilever is not a good cantilever is not a good option for a framed building. So we need to provide, we need to rectify, or we need to avoid cantilever beams as maximum as possible. So we should provide a floating column in order to avoid a cantilever beam. So I have provided a floating column here. Floating column, as you know, it will be starting from any story level. It will not be starting from the ground. It will be starting from a story level. So as you can see, this floating column has been started from the first floor level. So I need to start a floating column from the first floor level, that is here at this portion. That is, I need a column here. So for that, I'll be placing a column. I'll be placing a column at this portion. So you can see this column has started from the first floor till the terrace floor. Okay, this column has started since I have chosen only one story here. I have chosen the option one story here. So when I place the column at the terrace level, this column has extended till that one story itself. So it started from the first floor and ended till the terrace floor. So this is how we will place the column, and we will delete or replicate a column. So we have imported the beam layout from from the AutoCAD using .dxf file format. After that, we have replicated and we have created all the levels for beams. And after that, we have placed the columns. So after placing the columns, we need to make its base fixed. So as you know, at the base, that is the base portion of the column is fixed. So we need to select all the joints, all the column base joints like this. That is from base, you can select all the column bases and you need to assign fixity to it. So for that, assign joint restraints. So you know, uh, for a fixity condition, you need to restrain in every direction. So I'll be clicking this that is restrain in every direction, that is fixity condition, and I have applied this to the Etabs model. So I have made this column joint fixed. So next step is to provide the slabs. So the main part of a building is beams, columns, and slabs. I have imported, that is, I have drawn the beams here. I have placed the columns here, and the next step is to draw the slabs. So as you all know, slab is the covering portion of a room. So slab will not be coming at the ground floor. Slab will only be coming at the first floor and the terrace floor. So we will be moving up to the first floor and we will be drawing the slabs here. So in order to draw the slabs here, we need to, there is an option called draw floor slash wall. I'll be clicking that option. After that, I'll be picking each and every point of the grid so that I can draw a slab easily. So this is how you will be drawing a slab. Okay, this is a deck slab. So I don't need a deck slab. I only need normal slab. So for that, I need to change the option here. When I click this option, in this tab, I need to change the option to slab 110. So slab 110 means it indicates that the slab is of 110 thick. So after choosing 110, I'll be picking each and every point and I'll be drawing a slab like this. So there is also another way to draw a slab. Simply, you can choose the next option. There is also a next option like this. You can just pick the diagonals. So you can just pick the diagonals and you can just draw a slab. So if we do like this, it is more suitable for a square or rectangle shape. So if the shape is not square or rectangle, we should choose this option, which reduces error. So this picking up all the points and drawing the slab, that option reduces lots of error. So we'll be doing that. We'll be selecting like this, and we will be drawing slabs for each portion. So here I am not getting the joint. So I need to create a joint. I will be deleting this slab. So I need to create a joint here. So for that, I'll be dividing that frame. Okay. After that, I'll be drawing that slab again. Like this, you need to draw all the slabs at each row. Okay. Okay, this is a deck slab. So I need to change the property. So in order to change this property of deck slab, I'll be selecting that slab. I'll be going to assign. I'll be going to shell here, slab sections, and I can select the slab which I needed. which I need. So the slab 110 is the slab which I need, and I'll be selecting that and be clicking apply. So every this slab has changed to slab 110. So now every slab has changed to slab 110. And next we need to draw the slab for the terrace floor too. But there is an easy method. Here, as I have already said that all this floor plan is similar. This floor plan of terrace and first floor is similar. I can just replicate these slabs to terrace floor. So I'll be selecting these slabs and I'll be replicating that to terrace floor, story, terrace, apply. So this slabs has been replicated. Slabs too. Okay, this slabs has been replicated. It's an easy method to replicate the slab. So I have drawn, imported slabs, beams, and columns. So these are the major three parts of a building. So I have imported all these parts. So after that, the next step is to look into the architectural drawing and to make sure that whether there is cutout at any portion. So first, if we look into this drawing, there is a staircase here, isn't it? So for this staircase, we need to provide a cutout. That is, there will be no slab at this floor. So if there is a slab at this floor, we cannot access through the stair. We cannot access the first floor through the stair. So there will be no slab at this portion. So I need to delete that slab at the portion. So here, this is the portion and I will be deleting that slab because I need to access from ground floor to first floor. But in terrace floor, there will be slab because the terrace is the topmost covering. So there will be slab. So I have drawn beam, column, and also the slab. So the next step is to assign the loads. So after completing the framing of a building, after completing each and every point of a building, we need to assign the loads that is coming to it. So as you know, the loads coming to this building, particular building might be the wall load, live load, which is which will be acting on the floor slab. The wall load will be acting on the beams, and extra other dead load, imposed load, extra water tank load, like that. So we need to assign all these load into this model. So this is the final model which we have got. So as you can see in this 3D model, this is the final model of the building. This is a residential building. So this is the final model. So the next step is to assign the load. So before assigning the load, we need to check this model. So we need to check this model whether there is any errors. So for that, we need to move to analyze, check model, and in this select/deselect all. So all the options will be selected. After that, you need to untick this option because this option is trim or extend frame and move joints to fix problem. That is, if there is a problem in this modeling, this Etabs will automatically trim or extend the beams. So which is not good. So we need to, if it automatically rectifies the problem, sometimes it might lead to errors. So we'll be unticking that option and we'll be clicking OK. So we'll be waiting. The Etabs is checking this model. So model has been checked, no warning message were generated. So in this model, there is no warning message. Suppose if there is warning message displayed, we need to correct or we need to rectify all the errors. Warning messages may be due to this if this beam has not joined correctly, or if there is an inclination, or like if there is if there is no connection between slabs and beams, if there is overlapping, if there is extension. So if there is errors like this Etabs will be showing warning. So here this model is free of errors and free of warning. So we can proceed by applying loads. So for applying load, first we can apply the wall load. So wall load will be applied on the beams. As you all know, wall will be coming above the beams. So this wall will be supported by the beams. So this load will be acted upon this load from the wall will be acted upon the beams. So we need to calculate the wall load coming to the beam. So for calculating the wall load, we need to, the equation is width of the wall multiplied by density multiplied by height of the story. So this is the equation to find the wall load. So wall load means the self weight of the wall. Okay. So wall load means a self weight. So in order to find the self weight, we will be multiplying the width of the wall with the density into the height of the story. So width of the wall. So width of the wall we should measure from the AutoCAD drawing. So here if we measure this, it's 200. So width of the wall is 200 and width of the wall is 200. That is 200 mm. That is 0.2 meter. Density. Density of the brick is 20 mm and it depends upon the type of brick which is used in the construction. So if we use a solid block, the density of the solid block is 20, and if we use a lightweight brick, density of that will be 10. So it will be changing according to the brick that we use to construct wall. So here assume that we are using a solid block, that is its density is 20, and next is the height of the story. So height of the story can be calculated, as you know, as I said, the height of the story is 3 meter. So from floor to the next floor, it's 3 meter. So as you can see in this picture, uh, as you can see in this picture, uh, so here consider this is the basement beam. This is the beam at the ground floor level and this is the beam at the first floor level. So the story height from top of this beam, that is from this floor till top of this floor, that is this portion, is 3 meter. This is the 3 meter, that is the floor to floor height of this floor. Okay, that is 3 meter. So height of this story for multiplying, I mean height of this wall, we should multiply or we should reduce the beam depth. We should reduce the beam depth from the total height of this story. So assume we have assumed for trial we have assumed that beam has a depth of 400 mm. So we should reduce that 400 mm from this 3000 mm. So from this 3000 we need to reduce this 400 mm size beam depth. So 3 minus 0.4. So after calculating, that is 0.2 into density into height of story gives 10.4 kilonewton per meter. So this is the load that which we should apply on the walls, apply on the beams. So the load which we should apply on the beams is 10.4 kilonewton per meter, and we can look which all portion this wall is coming. So when we consider this full level, at this portion wall is coming. So we can select all the beams at that portion in the ground floor. We can select all the beams and we can apply the frame load. So for applying the frame load, we need to go to assign frame loads distributed, and here we will be selecting wall and we will be entering the value 10.4 and we will be applying. So 10.4 load is applied at this portion. So next we need to check the architectural drawing. Yeah, here too, in this portion too, there is wall. So we will be selecting that portion and we will be applying the load. Moving back to the architectural drawing. Uh, when you when you look into this drawing, here, and this portion too, there is wall. So we can select that portions and apply. So we have applied load at that portions too. And here also there is wall. Uh, here also there is wall. Here also there is wall. So here, here, and here, we will be applying the load. So next, when we look into this portion, you can see that in this architectural drawing, the size of the wall is less, isn't it? The size of the wall is, this is a partition wall. So let's measure its size. So the size is only 100, that is 0.1. So the size of that wall is less. So we only need to apply load coming to based on that wall. So here this 0.2 will be changing to 0.1. So for partition wall, the load will be less. So it's almost 5.2 kilonewton per meter. So for this particular wall, the wall load is 5.2 kilonewton per meter. So we'll be applying that too. So after that, when we look into the here at this portion, there is no wall. At this portion too, there is no wall. Here also there is no wall. So that so we will not apply wall load here. We only apply wall load at the portion where walls are coming. So in this ground floor, we have applied loads at the portions where wall load is coming. So now let's move on to the first floor. So the same procedure should be done in the first floor too. So we need to check at which all portions wall are coming. So same as the ground floor, all the exterior portion, the walls are coming. So we can select the exterior portions and apply the load. 10.4, apply. And I will be breaking this. Okay. So when you look into this portion, this is an open terrace. So here there will be no wall extending till the next floor. So open terrace, there will be parapet only. So we need to apply the parapet load at this portion. Okay, there will be no wall rising from this first floor to terrace. Only there will be parapet. So we need to assign the load of parapet only. So for that we need to calculate the parapet load. So for calculating the parapet load, say the height of the parapet is 80 centimeters, that is 0.8, and width of the wall is 15.15 into its density 20. So only 2.4 kilonewton per meter load is acting on it. Since there is only parapet at this portion, only parapet load will be coming to this beam. So say the height of parapet is 80 centimeter, say the thickness of the beam, thickness of the wall is 15, that is 0.15 meter, and density is 20. The load will be only 2.4. So we will be applying 2.4 load at this portion since there is only parapet. So I have applied 2.4 load at this portion, and rest of the portion I need to apply loads like this. So here now we have in this class we have learned how to import a DXF file to Etabs, and we have learned how to assign all the how to place the column in right position, how to change the axis of the column, how to draw slab, how to delete or apply have to delete the slab, etc. So we have also learned how to apply, how to calculate the wall load, how to apply the wall load into beams. So the next will be continued in the next session. Since the time is over, we will be continuing the balance in the next session. So I hope you have understood the class. Is there any doubt? Hello.
Hello, anyone have any doubts on this session? Thank you, Neha.
Thank you. Thank you, everyone.